So in this video, we're going to talk about how to use regressions and Desmos to write linear functions and make predictions from a set of data. So when you plot data points on a grid, the resulting graph will be called a scatter plot. By looking at the pattern the data points in a scatter plot, you can draw in a trend line like this one shown here to represent the pattern that's in your data. Trend lines are considered to be a good fit or a bad fit depending on how well they represent the data in the graph. So, how do you find the equation of a trend line? You can actually find the equation of a trend line by performing what's called a linear regression in Desmos. And what Desmos will do is it'll actually give you the equation of that trend line. It'll also tell you a value called the correlation coefficient, which is represented by R, and that tells you how well that equation it gives you fits the data. If your correlation coefficient is closer to 1, that means your equation will be a good fit for your data. So the steps to performing linear regressions can be also found in the study guide that's posted in the resource folder. So make sure you're using that guide when you're working on your assignments. So let's start off with this example. Let's enter the data in this table into Desmos and go ahead and apply a linear regression to determine a function that best represents this data. So here's what we need to do. We need to first click on this plus sign for add item and then click on table. And then what we're going to do is we're going to type in this table exactly as it's given to us in the original problem. So I'm going to go ahead and do that now. And you always want to make sure and double check and verify that you've typed in everything correctly. And then what we're going to do is we're going to click this little add regression button that shows up right here. And then once you do that, it's going to go ahead and calculate a linear regression. You can see that as we're typing in the data points, it plots the scatter plot. And then when you do the linear regression, it'll give you the equation of the line and it'll graph it over your data points. So that equation that it gives us is y equals 2x plus 5. Notice here it also gives us the r value. It says r equals 1. And so that means that this line is actually going to be a perfect fit for our data points because you can see it passes through every single data point that's on our graph. So now you can go ahead and pause the video and try doing this example on your own. So here we have a whole new set of data, but it's going to be the same process as before. So you go to table and then you just go ahead and type everything in. And then once you've done that, you're going to go ahead and do add regression. And then the linear regression tells you the equation is y equals negative 5x plus 13. It says r equals negative 1. So this line is actually going to be a perfect fit for this data. So now let's look at this example. It says that Artemis works as a computer graphics artist for a major video game manufacturer. He's paid a monthly salary of $3,350 and he earns a bonus of $200 for each frame model he produces. The table shows the amount he earns in a month depending on the number of models he produces. Using Desmos, determine a regression equation to model this data. Okay, so let's go ahead and type in all our values. So once again, go to plus and then table, and then let's type this all in. And so now we're going to click add regression and then do our linear regression. So it tells us the equation is going to be y equals 200x plus 3350. And it tells us the r value is equal to 1. So that means this line is going to be a perfect fit for our data. And notice here, I can't actually see my scatter plot or my line on the grid. And that's because I have larger values here. So you can always adjust the zoom in Desmos. And then if we scroll around, you'll be able to find your graph. So regression equations can also be used to determine future values in real life situations. All you need to do is write the regression equation as a function and then substitute the given value into the function. And this is actually a really important application of regressions. So what am I talking about? Well, what I'm talking about, let's look at this previous example that we just finished working on. So we were talking about Artemis's monthly earnings, and remember the equation we found was y equals 200x plus 3350. Well, what if it asks us how much would he earn in a month if he produces 8 frame models? So remember, our frame models was our input value. That was our value of X. So what I'm actually going to do to figure this out is I need to figure out, well, what is this equal to when X is 8? And so you can substitute directly into this equation, or if you want to use Desmos, what you can do is rewrite this equation, but instead of y, I'm going to write f of x. Okay, so I'm going to write f of x equals 200x plus 3350. Okay, so same equation I had, I just replaced y with f of x. And then what I do is I'm going to ask Desmos to tell me, well, what is f of 8? Okay, so you see what I'm doing is I'm replacing x with 8, and it does the calculation for me, and it tells me that he's going to earn $4,950. Okay, so you can actually use Desmos to figure out values that are not given to you in the table once you have the regression equation. So now let's try this example. A meteorologist collected the following data on the amount of snow in feet for different elevations, find the equation of the line of best fit, and use it to predict the amount of snow for an elevation of 10,000 feet. So I'm going to go ahead once again and then do the plus sign and then table, and I'm going to enter all of these values into Desmos. Okay, so now that I have all my values entered, I'm going to go ahead and click add regression, and then you see it automatically does a linear regression. So I'm going to round my coefficient so I can write out this equation. So I have 0.0019x and then minus 3.27. Okay, so that's my equation. Here it says predict the value at 10,000 feet. So I'm going to go ahead and rewrite this equation using f of x. So I have f of x equals 0.0019x and then minus 3.27. Okay. And then what I'm going to do is I'm going to replace x with 10,000. So I have f of 10,000 now. And you can see it tells me 15.73. I'm just going to go ahead and round to the nearest whole number because it looks like that's what they've done in this table. So I'm going to say that this is about 16 feet of snow at an elevation of 10,000 feet. So now you can go ahead and pause the video and try doing this example on your own. So here, Corinne is collecting data based on the amount of time she plays in basketball games and the number of points that she scored. What's different here is my table is actually horizontal, okay? But keep in mind that whatever your input value is, so in this case, your time played, that's going to be your X, and the output is going to be Y. So when we type this in Desmos, we kind of have to turn this table sideways, but it's okay. You can go ahead and do that. Just keep the X values all in the left column and the y values all in the right column. So I'm going to go ahead and enter this data so you can see where I got this equation from. And so I'm going to do now add regression, and it does give me the linear regression. You can see I went ahead and rounded to the hundredths place. So I have 0.88x minus 10.49. The R value is 0.98, so that's a pretty good fit for this data. So now I need to figure out how many points she would score if she played for 20 minutes. Once again, I'm going to replace y with f of x. So I have f of x equals 0.88x minus 10.49. And then I'm going to ask it to calculate f of 20, right? So how many points does she score if she plays for 20 minutes? So it tells me 7.11, but I don't think you can score a decimal value in a basketball game. So I just went ahead and rounded it to the nearest whole number, and that means she'll score 7 points. So using regressions and Desmos, you can actually write a linear equation that best models a set of data. You can then use this equation to calculate values that are not included in your data set.